Today I'm going to present my final year report on the analysis of machine learning models and technical analysis of the SPY ETF. So first, what is trading? Trading is when you make buy and sell decisions for some asset in a market, be it stocks, bonds, or options. Nowadays, due to a large improvement in computing power and networking speed, the competition and volume in the trading landscape has evolved greatly since its inception, leading to a significant amount of data being generated. As a result, in taking advantage of this data, researchers have found that machine learning models have very interesting use cases in trading, especially for price prediction. However, researchers disagree on which models perform better for price prediction and trading. Moreover, there is not enough research on temporal features for machine learning models, that is, features that incorporate time as a variable. Examples of temporal features include the speed of price change and the frequency of trading. That brings me to my objective. My paper aims to deepen research into price prediction and trading strategy generation. My contribution will be by examining and contrasting popular machine learning models and their abilities in price prediction. I will also compare and contrast the impact of the temporal indicator speed and frequency on price prediction and trading capability. The models we'll be evaluating are LSTM, GRU, and ARIMA. For the models we are evaluating, there will be combinations of the OHLC of the price series with speed and frequency. We're going to be performing the evaluation on the SPY ETF price time series, which is high frequency data from the years 2016 to 2023. So now we discuss the literature review. In this review, we are going to look for research for feature selection and model selection for price prediction. For feature selection, we consider literature around technical indicators. Technical indicators are a broad term for mathematical formulas generated from the price series itself. For example, using price or volume. They have been used to good effect. A study performed in 2023 used technical indicators to improve a crude oil trading strategy. However, most studies that use technical indicators use price or volume to create indicators that are commonly used, such as the exponential moving average or volume-weighted average price, and few use temporal information, as mentioned earlier. One of the few studies that utilize temporal information use convolutional neural nets to encode temporal features into models, achieving a high rate of return of 50% annually. Therefore, it is important that temporal features, such as speed of price change and frequency of trading, should be further researched. Now we can discuss models used in research. Many varieties of models have been tested, such as XGBoost, support vector machines, deep neural nets, k-nearest neighbors, as well as sequential models such as the LSTM, GRU, and ARIMA for price prediction tasks, where the last three are our focus today. What is interesting in the literature is that there isn't a standard agreed upon model configuration for each study, so it is difficult to have an objective comparison between authors. However, a study found that the LSTM had the most articles written about it from 2011 to 2021 in finance literature compared to other models. Therefore, the LSTM is interesting to investigate. However, within LSTM research, there are conflicts between its performance compared to other models. For example, studies conflict in whether linear models like ARIMA perform better, whether combined LSTM models perform better, and whether other sequential models, such as the GRU, perform better than a single LSTM model. Therefore, it is necessary to evaluate LSTM performance versus the ARIMA model, the combined model, which in our case will be an LSTM-GRU combined model, and other sequential models, which in our case is a single GRU model. Now I shall discuss feature engineering for this paper. Well, after data cleaning, we aggregated the trade-by-trade data into sets of 100, and we take the open, close, high, and low prices, which is the commonly used in finance OHLC format, of the aggregated set. As is shown on the screen, these are the different formulas that we will use to create our indicators. Return is the price series difference by 1. We have return rate price series difference by 2, as well as speed and frequency. These are the different feature sets that we will test and compare with. As you can see, each of these feature sets has the OHLC, return, and return rate as constant features. SO adds speeds as well. T0 adds frequency. ST has both speed and frequency. N has neither. In order to evaluate our models, we use the metrics Sharpe ratio and PNL for trading metrics. We use the metrics RMSE and accuracy, which is directional accuracy, to discuss predictive ability. We also create a very basic trading formula that buys if the prediction is higher and vice versa for selling. Now we move on to the results and discussion. We consolidate the results for different years by averaging them out and then discuss the consolidated results. Here we'll assign rankings to each model and feature combination, 1 to 4 from best to worst, and then we shall discuss the rankings achieved by each model and feature combination. First, for Sharpe ratio, The LSTM GRU model has the best Sharpe ratio. The ST combination is the highest performing indicator combination for Sharpe ratio, while S0 is the worst performing. The T and N combinations have similar Sharpe ratios. Now shall discuss for PNL. The LSTM GRU model again achieves the highest PNL, and Remax is the worst performing PNL. And this is surprising since it had higher Sharpe than the LSTM and GRU, although the higher Sharpe may be attributed to disproportionately lower volatility. For indicators, ST again has the highest average PNL across all models, indicating its effectiveness as an indicator combination. Now I shall discuss prediction metrics. The LSTM model has the best average root mean square error, while the worst is Remax. The S0 indicator combination has the worst performing root mean square error. The ST combination, for a third time, has the best performance for this matrix. However, in discussing directional accuracy, the Remax has the best directional accuracy across all indicator combinations, outperforming the sequential models. Additionally, it is noteworthy that the S0 indicator combination has the highest accuracy. This suggests that the information on the rate of price change with respect to time is valuable for directional prediction. Since we assign a ranking to each model and feature combination for the consolidated metrics, we can have a better perspective by evaluating the rankings table. As we can see, the LSTM GRU model achieved the most number 1 rankings and came second and third for accuracy and root mean square error, and therefore it performs other models in trading ability but not necessarily predictive performance. However, and this may be due to the fact that it has a more complex structure that is able to capture more complex market dynamics. However, it is not totally clear that the more complex structure leads to better performance. The LSTM had similar performance to Remax. LSTM had better root mean square error. Remax was better at directional prediction. For indicator performance, we may say that ST is the best indicator because it has the highest number 1 rankings and does not have any ranking below number 2. It is the highest metric. It is the highest in every metric except accuracy. However, we are not able to claim that the S0 is the worst performing indicator set, as it arrives first in the category for directional accuracy. This brings me to the end of my final year presentation. We have discussed the predictive and trading performance of a single LSTM model, a single GRU model, the ARIMA model, and a combined LSTM GRU model. We also discussed the performance of the feature sets S0, which includes speed, T0, which includes frequency, ST, which is both speed and frequency, and N, which has neither speed and frequency. We discovered that the LSTM GRU may be considered to be the best performing model, and the ST indicator set may be considered to be the best performing indicator set.